Good afternoon. Welcome to session 18. Today what we'd like to do is talk a little bit about batching and mixing and transportation of fresh concrete. We're going to take a little bit of a divergence from what we've been talking about up to this point. You'll remember that as we've been talking about, the first third of the semester is really related to constituent materials. So if we put a box around that, this is sort of the part that we've covered to this point. We've been talking really about cement, aggregates, mixture proportioning, really talking about the general constituents. The second thing that we're really going to be talking about is this portion toward the bottom here now, where we're going to start to talk a little bit about the idea or the concept of processing. The last third of the semester, we're going to talk about properties, or we're going to start to talk about the mechanical properties and durability properties of the actual concrete, and all these will get together and will be combined to really talk about performance of the overall concrete system. Now, this you'll see this type of a diagram drawn frequently. It'll either be three circles all intersecting at performance, or you'll see people drawing these as different legs on the side of a triangle. This is something that's fairly classic concept that was thrown out for the material science of looking at building materials. In the 1950s, there was a dramatic change from the way that each material was being considered to sort of looking at a more scientific approach. And this is really centered on a book that was put forward by a guy named Frankel. And Frankel was on sabbatical. He was at the Northwestern, where they were starting up a new material science program. It would turn out to be the first one in the country. And Frankel wrote a book that really dealt with two large sections of this. He wrote a book where he talked about the fact that we really needed to know about the constituent materials, and that was about the first half of the book. The second half really dealt with properties and really looking at material properties in sort of a fundamental way. And then, I know I've already covered two halves, so the book should be over, but there was actually one chapter at the end, and it's actually a two-page chapter, which makes it kind of interesting. But Frankel goes on to say, I think processing is kind of important, and we'll see this developing over the next 40 or 50 years. So when you hear people talking about the material science concept, this is really where it starts to take place. Now, when we start to look at the material science model sort of applied to concrete, we see this in a little bit different light. We see the constituent materials. We are dealing with a structure that's a heterogeneous material. Right? We've got large aggregate. It's relatively large scale at the size that we're normally looking at the concrete at. So the aggregate here is a heterogeneity that's at a size that's really visible to us. There are a lot of other materials that have flaws or have components that are put together, but generally at a much smaller scale. This fact is going to come on later on, and it's going to influence a lot of the properties that we're going to be talking about. It's going to influence a lot of the aspects of processing and property testing. Right now, we're going to start to deal a little bit more with this leg over here, where we're going to really talk about some of the specific aspects of processing. And I think this is an avenue that really gets shortchanged when it comes to a lot of the good discussions on the overall performance of concrete. Processing is incredibly important. It's going to influence our material properties in a major way, but most of the time people don't spend a lot of time either considering it, or the only thing they worry about when it comes to processing is what? What do you think the main thing that industry is worried about when it comes to processing? Cost and
how many people it takes?
How many people it takes, that's a part of it. The Steelers, when they were the great dynasty in the 70s, used to have the great shirts that said bigger, stronger, faster. That's sort of the industry at large. All right, if we can go bigger, we can go faster. All right, there's more profit. People are really excited about this. So the main areas where you've seen processing take off, and the areas where you've seen processing really pushed forward, is in the idea of, can we save money, can we get it out more quickly? I think one of the avenues that's really lagged behind here is the sort of the science of processing, and what is it that we actually need to make the material as good as we could actually make the material. A lot of times we say, well, how much curing do we have so it's just not detrimental? Or how much mixing do we have so it's just not detrimental? I think there are advantages that we could start to take here, and we could start getting this really wrapped up in the overall performance and properties that we're talking about. Now, the majority of the concrete that you are going to encounter in your life, depending upon what application you are in, is likely going to be ready-mix concrete. Most common way that this is going to be ordered, at least in this country, is by the cubic yard. You could order it other ways if you would like, but most people are going to translate that over for you into cubic yards, at least in this country. Other countries, you may be able to order it by the cubic meter. What you will find out is a cubic yard is very, very similar to a cubic meter, although they are not exactly the same. Many times here, the truck is not only the cardboard box that brings the thing from Amazon out to your site, the truck is also the mixer. Now this isn't exclusively true, but many, many times the truck is, in addition to doing the shipping, it's also doing the mixing that's bringing the concrete out. Couple of things that you should keep in mind. A cubic foot of concrete generally weighs about 145 or 150 pounds, which means that a yard of concrete is generally going to go about 2 tons. This is normal concrete or normal weight concrete. So a full truck of concrete is generally about 20 tons and generally is going to have something between 8 and 12 yards on a full truck of concrete. Now it's going to depend upon the state that you're in, what configuration that truck has, and how many axles that truck has, and if it can deliver in the spring the same way it delivers in the summer. But in general, this gives you some idea of how much is on each truck. And if you don't know what a cubic yard of concrete is at this point, I should throw you right out of the room. But I won't. I'll actually take the time to explain it. We're talking about a box of concrete that would fill a yard by a yard by a yard. So 1 yard on each side. If we filled up a bunch of boxes like this, we would fill in 9 of these out of the back of a typical ready-mix truck, which you can see listed over to the right-hand side. Now, if you order concrete, generally you're going to have to figure that volume out. So you would go through and you would figure out the overall volume that you would need. So for example, you can see here, and I've guessed at these pictures since I didn't actually take this picture. It's from Portland Cement Association. But if we assume that it's about 30 feet between these two forms, and we're placing it something that's about 4 inches deep and 60 feet long, all of you could use the advanced calculus that you've taken. You could form a differential equation to figure out the volume of this rectangle, and you would do a calculation that would look something like this. You would take your volume, you would convert it over to yards, and you would come up with something around 22 cubic yards. So with the information that I just gave you, you would say 22 cubic yards is more than we can fit on a truck, and we'll talk about that in a couple seconds. So there are going to have to be multiple trucks coming out to the job site. You will also encounter something in the industry that is fantastically interesting, and it is a little stick that looks like this. This is a stick that's sort of a slide rule. It's a plastic type stick. I forgot to bring mine with me. I'll bring it to the next class. You can look at it. This is sort of a magical stick because it has numbers on it, and people can do very quick volumetric calculations with this slide rule concept. So the center part slides with some numbers on it, and essentially what they're doing is this is a very quick, easy way for them to estimate the volume. The thickness of the floor slab that they're doing is 4 inches. They set the width, they look at the length, and on the bottom it will tell you the overall cubic yards of concrete that you need to do this. This is something that was set up so that it's very easy to estimate the amount of concrete. Now, one thing that I will point out here is whether you do 4 inches, 3.75 inches, or 4.25 inches can make a big difference on the yield that that concrete is going to have and whether you fill up the forms. So there are a few things that you need to do when you're looking at this, and in such a small pour, this isn't such a big deal, and I apologize for bisecting this gentleman here with my rectangular areas. But the basic idea is the first yard you may have first truck you may have 9 yards, second truck you may have 9 yards, which would leave 5 yards on the last truck. But sometimes we can start to take advantage of the fact that the cell phone is our newest best friend. You can be calling back into the dispatcher, so you should have an idea of how far each truck is going to be able to go and make sure that you're meeting the yield that you're expecting to have. So again, the dispatcher is going to be your best friend, but you need to communicate. I will tell you, after spending years on the other side and working at a plant, there is nothing more frustrating to the dispatcher than sending out a 7-yard truck followed up by a 1-yard truck. There's nothing more that's more irritating to you for paying for that 1-yard truck that comes out, because you are going to pay extra because it is a light load. So one of the things that you really want to keep track of is how much material is going out on the job site. You want to sort of have a mental note. Sometimes you'll even see on different jobs, you'll see someone come along and spray paint on the ground how far each truck should be going so that you've got an idea if you're going to run short or you're going to run long. And then you really want to try to keep in contact with the dispatcher, because while you're worried about your job, the dispatcher has another 15 to 20, 30, 40 jobs going on depending upon the area that they're working in, and they're trying to keep everyone with concrete so that they're not running out of materials and they're no cold joints for anyone in town. Some other things that you should be ready for when we start to talk about the idea or the concept of ordering concrete is the idea for different ways that the concrete can be specified or ordered. There are really three methods here. These will differ slightly from what we talk about when we talk about prescription and performance specs later. But the basic idea here is you can order concrete where the purchaser, that would be the person who is buying it, specifies only the compressive strength, and then they basically leave it up to the ready-mix supplier to come up with the mixture proportions that are needed to obtain that compressive strength or whatever other properties that are out there. Now, I would say that few of us would go to a five-star restaurant and then we would give someone a recipe and say, oh, by the way, if you could hand this to the chef, this is exactly how I would like my Cheerios prepared today at my five-star restaurant. This is sort of the same idea here. You're going to a ready-mix producer. You're choosing a particular ready-mix producer for a reason. They generally are going to have much better information on you on how their particular materials combine, what types of properties they yield. So the general idea is leave it up to the chef who knows best how to make the material and tell them what you want at the end. If you want a tasty steak, tell the chef, give me a tasty steak, and let the chef figure out how many minutes to cook it, if he wants to use oil, if he's going to use pepper, something like that on the way there. So this is really the method that people are really starting to push more and more towards now, because what they're really asking is they're asking the producer, just supply what it is that I want. I want a concrete that's going to last for 20 years. I need to have compressive strength of this, a chloride resistance of this, a freestyle value of this. Just supply that concrete. I'm not going to tell you how to make it. The older type of ways that this is done, and this is typically when agencies are purchasing the concrete, when a DOT or Highway Administration or Bureau of Reclamation or something like that is purchasing the concrete, they are going to specify the mixture proportions. And they're going to say, give me 564 pounds of cement, give me a water to cement ratio of 0.42, give me 1,200 pounds of aggregate, and I want that concrete. Now there's a big difference here, because they are giving you the recipe, and in theory, you are just mixing their materials together and delivering it to them. They are assuring the performance is going to be obtained. They should be making any sort of changes on site to this. I think this is a little bit of a trickier way to go in the prescription spec, and you're seeing a lot of people move away from this. It's great in an area where you don't have a lot of experience. However, it really loses out on allowing people to really optimize their overall process. What you'll see very frequently is the idea of mixed options, where the concrete producer will be asked to select their own mixture proportions given certain requirements on cement contents or requirements on compressive strength, things like that. I think over the next 20 years, if you want to take something and you want to bet on it for what's going to happen in your career, I think you're going to start to see more and more people move away from prescription and move towards performance. The process is becoming more and more complicated. The available materials are becoming more and more complicated. The idea to develop special materials is starting to really take off. The idea of relating these to life cycle is really taking off, and you're seeing a huge push right now in the industry to move away from performance, or move away from prescription and move to performance. In fact, the ready-mix industry has an initiative that's out there called P2P. P2P is prescription to performance. All right. So they're trying to move away from the prescription side and moving toward the performance side. You'll see the paving contractors will be doing things called pave spec, where they're really trying to move towards performance-related specifications, and it really gives the contractor a whole lot more flexibility to do what they need to do. It gives the producer a lot of flexibility. Now, each of you probably have been waiting in class to ask the question of where concrete comes from, and I could tell you that it comes from a stork and it's dropped down the chimney, but that would be a lie. I'm going to give you the nitty-gritty details, the birds and the bees, as it were, of where concrete comes from. We'll take a little bit of a look at the idea of a ready-mix plant and what's going on, and then we'll talk a little bit about what's happening inside of a truck. So you'll remember we've got these different proportions, and remember, while we talk about proportions by volume quite a bit in this class, the only people who are excited about proportions by volume in large part are engineers. The reason we're excited about proportions by volume is shrinkage is going to be related to volumetric components. Compressive strength is related to volumetric components. You noticed when you had to estimate the compressive strength of a paste, it was related to the volume of the constituents inside of the material. When we have to talk about diffusivity, it's related to the volumes of the material. So all the engineering properties are typically traced back to volumes and the way that those volumes are connected together. So typically we need to know something like the volume fraction and something like a spatial distribution type of characteristic, and we can pretty much describe most of the material properties. However, unlike the idea of cookies like we talked about before, when we start to move on into real production, we need to move away from volumes when we think about large scale, and we need to start to talk about the idea of trying to do this in terms of weights or masses. And one of the main reasons for this is around the world, contractors are typically paid by the piece. So if you hear people talking about this, it's fairly common in the commercial applications where you get paid per cubic yard of concrete that's supplied. You get paid per square yard of pavement that's put down. So people are being paid in a slightly different way, and what they really want to do is they really want to start to figure out how they can start to relate this back to speed, because speed is what's going to make up the biggest difference in money. All right, so if a contractor can provide more material, there's more material that they're going to be paid on. So they really want to be able to batch this concrete as quickly as possible. They want to be able to ship it, get it off the trucks as quickly as possible so that they can turn that truck around and make more money with it. They've paid the exact same amount for the driver. The truck is essentially exactly the same. So the way for them to really increase the profit is to really turn the equipment around and really come back to trying to do it as quickly as possible. One of the other things that I'm going to point out here, when we're in the lab, it's a little bit different process than when we're out on site. When you're in the lab, and I'm sure that each of you have done this, I watch it each semester when we do a class like CE 331, where students make a batch of concrete and they spend a good 10 to 15 minutes deciding whether that last rock really should be in the coarse aggregates when they weigh it out, because the numbers weren't exact on that scale. You have to remember that while you're in the lab, yeah, you can take the time, and you should be taking the time to make exact duplicates and spending a week and a half to measure out just the exact right amount of sand that's inside of the system down to that last grain of sand. And we've all done it, I think, where we exchange that one big rock for two smaller rocks because it gets just a little bit closer in the lab. Right? In production, you aren't using a 4-inch scoop. You are using a 6-yard bucket or a 4-yard bucket. Right? We are dumping the materials in fairly coarse fashion. We are batching the trucks fairly quickly. All right? When I was working in the asphalt on the asphalt production side, every 3.5 minutes, a fully loaded asphalt truck needed to be headed out of the plant. If it was not happening like that, I was getting a phone call. What is the holdup? Why are trucks not leaving? 20 yards, 20 tons of material every 3.5 minutes. That's what it takes to pay off the plant. That's what it takes to make money. You're going to see the same thing here. So you're not going to see people going to smaller and smaller scoops. You're going to see people moving to higher and higher production. How can we get the most out of this particular plant that we've got? This brings up a few interesting aspects. Not only do we have to be able to batch these materials quickly, but also how accurate do you think you're going to be able to be in using this loader bucket to pick up just the fine layer of sand that's right over the top of this concrete pad. All right? And it's very frequent that you're going to see people getting into things and using materials differently than what they should be doing. Right? Now, I took the weekend to draw this picture. Oh, that's a lie. I didn't take the weekend to draw this picture. This is from the Portland Cement Association Design and Control of Concrete Admixtures. But it's very cute if you wanted to set up a little diorama or a terrarium of a concrete plant in your living room this evening. You could go ahead and do this. The basic idea here is somehow rocks are going to get to your facility. The aggregates are really where it all starts. Those aggregates can be brought in. Some places they're going to be brought in on barge and they're going to be offloaded. Some places they're going to be trucked in on a daily basis. Some places they're going to be trucked in and they're going to be stockpiled. I think one of the trends that you're going to see happening in the industry more and more as real estate becomes more and more costly, I think you're going to see a lot less aggregate being stockpiled at the production facility, and you're going to see a lot more being trucked in on a day-to-day basis. Now, what impact does this have on the overall production? What do you think happens if you're using the aggregate as quickly as you can bring it in on a truck?
There's more risk involved.
There's going to be more risk because you may or may not get the aggregates that you think you're going to get. So you got to have a different quality control procedure. The idea that the moisture content of the aggregates can change is going to depend a lot. And also there's a whole risk associated with, is there enough aggregate to even keep the plant running? What happens if there's a traffic jam that happens today? There's another little risk that happens, especially when you get a lot of new drivers coming in, and especially where the drivers are delivering their own materials. And I know this sounds like it's silly and no one could possibly ever do this, but it's very frequent at plants that someone dumps the wrong material in the wrong bin. So you expected to have coarse aggregate in the coarse aggregate bin, and bonanza. Today you have sand, at least one truck full in that bin. All right, so these things have to be clearly specified because if not, all right, they are going to be problems. Aggregate stockpiles. As we talked about, aggregates come in two main flavors, coarse aggregate and fine aggregate. I will also mention here that there are some producers that are moving toward a third aggregate or an aggregate that they're going to blend, or they may have a few different types of coarse aggregate that they're using. So especially if you're blending aggregates together, it's very common to see problems if people aren't really clear and it's not clearly labeled where they need to be dropping off the material. Where these materials are stockpiled, they need to avoid contamination and they need to avoid segregation. Every time you handle rocks, every time you handle aggregates, you have the potential to screw it up. Nothing has ever gone well. Nothing ever goes great when you start off with aggregates. You never make them better by touching them. Every time you touch them, you have the potential to ruin what's going on. Now here you can see a few things. You can see that these are in bins where there are concrete walls in between them, and that is to avoid contamination, where these rocks are going to get together and mingle with this sand that's over here. One thing that you will start to notice is at this facility, you are getting outside of the region where the materials are well contained, and you got potential for cross-contamination. All right, one of the other big issues that you're going to have now in both of these facilities, they are on concrete platforms, so you're not going to get the loader operator digging down into the subgrade. But one of the problems that we ran into most frequently was an overzealous loader operator who really wanted that last couple inches of aggregate. And he would try to scoop it up out of the bottom, and all of a sudden he would have a big ball of mud, 2 soda cans, and something else that was being thrown through the system. So you really want to make sure that you're avoiding contamination not only from the bottom, but also contamination from the other aggregates that are present. Loader operator is going to want to work uniformly across the face. By working uniformly across the face of the aggregate, there are two things that it's going to allow you to do. It's going to allow you to minimize segregation, and it's going to allow you to have a much more uniform moisture content, so you're not going to have big spikes in the moisture content. If you have someone who's burrowing into one section of the pile, and then he starts over and burrows next to it, what you're going to have is something that goes from either a dry or wet material to something that's wet. Then they start over with a dry or wet material, they go to something that's wet. And it's going to be mixing as it goes through the plant, and it's going to be really difficult to control. If you have someone who's working uniformly across the face, you're going to have materials that are relatively consistent. So if they are changing throughout the course of the day, the sand's getting a little bit drier or wetter as they work their way into the pile, you're going to be able to account for that. You're going to be able to make adjustments for that, and it's not going to be as random as you walk through. If it's not on a finished base, you want to leave a little bit of material down there, and then separation walls, which are what we were talking about before. Right? Aggregate bins. This may sound somewhat trivial, but I hear this brought up quite frequently. Many plants have 2 aggregate bins. So in order to emphasize that, I have shown you a picture with 3 aggregate bins. You will see that there are 1, 2, 3 aggregate bins at this particular plant. That is not common for especially a lot of the older plants that are out there. Many of them have 2 aggregate bins because there are 2 flavors of aggregate, sand and coarse aggregate. Putting in a 3rd bin is expensive for that particular producer. So even though you may have the greatest mixture proportion design that's ever been known in the history of mankind, if there is not an incentive, and typically a financial incentive, for a producer to adopt that, to take on the cost of putting in the extra aggregate bin and now all of a sudden dealing with the fact that they have 3 materials they need to run quality control on, you're not going to see that implemented. So you'll see a lot of people talking about ternary blends of aggregates, 4 blends of aggregates, doing all kinds of different things. It's a lot of times it's restricted by the equipment that's out there in the industry at the current time, and you need to know what's locally available. You need to know what's locally available to particular regions that you're working in. Now, if you're working in a major metropolitan area, this is not typically going to be a problem. However, if you're working in other areas where 2 bins is typical, you need to work on the assumption that you're going to have 2 bins. Okay. Bins are going to store the aggregates before they are batched out and weighed. One of the things that you will see is conveyors can frequently move the material from the bins into someplace else on the plant. Here you'll see a couple different options here. Here you can see one option where the aggregates are actually being stored and the bins are underground so that they're just simply driving in over top of the bin. They're dumping the aggregates through there and the material's going then on through the plant. One thing to be a little bit careful here, if they're driving through over top of the grates, sometimes trucks, especially when they go into quarries, can pick up very odd things. Like lots of mud and other things that can be dropped in on top of the material. So you want to be a little bit careful about that. The other thing that I will point out is on the bottom of each of these bins, if you got really close and personal to what's happening down here, you would see something that looks like this. This thing on the bottom is essentially a clamshell gate. It is now open. When it is closed, this will swing down, this will swing down, and in theory, no sand or aggregate is going to get through there. The way that they're typically weighing the materials out to put them onto the conveyor, there's going to be a scale somewhere in the process that's going to drop out of this bin onto the scale or onto the conveyor belt directly. And the way that we stop adding aggregate is we close these gates. So you have to think about the precision involved in closing those gates. It's kind of like if you were dumping sand into the back of the mixer, in your backyard or in the lab. Imagine having your hands in front of it, and all of a sudden you're going to stop it by closing your hands. All right, and that's the accuracy that you're going to be dealing with in these types of applications. Okay. The next thing that we're going to see in the schematic of the old ready-mix plant here is we are going to have silos, and those silos are typically going to be the binder materials. They're going to be our cement and our supplemental cement. So again, we've got the silos here. You can see some pictures of some nice silos. The cement is typically going to be moved from a cement plant in a semi-truck. This is actually what a cement truck really looks like. It is not the truck that's rolling down with the big barrel on the back. It is a tractor-trailer type truck. It will essentially take the material, and you will have essentially something like the world's largest shop vac that will suck the cement out of this truck and will blow it up into the silo. There are a few things that I will point out here. Much like aggregate bins, many plants will have 1 or 2 silos. Now, what is the practical implication of this? It's kind of like going to your favorite bar. You may wish that they had 75 beers on tap, but they have 2 on tap. And if you want anything else, you're going to take it out of the bottle. Same way here. If you go to a plant that has 2 silos and you want to add anything else into the mixture, you want a ternary blend or a quaternary blend, or you want a different type of cement, you better have a different way of adding that to the overall system. So I've shown a picture here that's commonly used for something like silica fume, where you may see smaller bags of those materials being added in, or you'll see them added in bags into the back of the truck. There are a few other things that I would point out here. One of the things that is fairly problematic at some ready-mix plants, and you should be aware of this, is the idea that to a driver, the shop vac system for cement looks exactly the same as the shop vac system for the fly ash. If you get your fly ash and cement backwards, it's a big deal. And this happens somewhat frequently enough that it's something that you need to be very concerned with. Make sure that when your fly ash is delivered, when the cement is delivered, they're hooking it up and putting it in the right spot. Many places you will actually see they will have padlocks, and the driver needs to come and get the correct padlock for whatever material they're dropping off. And the idea there is to try to minimize the potential for mishap by putting fly ash or cement in the wrong silo. The big problem there is it's down the road, the concrete has been produced, and you thought you had a mix that had 20% fly ash. It actually has 20% cement. And now you've got a quarter mile of it placed. And what do you start to do about the problem? And it sounds like it's something that's fairly trivial, but it happens. It's happened in the state of Indiana. There's been a section of pavement that's picked up. Happens quite frequently with ready-mix producers. So this is something that you need to keep account of. Obviously, cement needs to be kept dry. The equipment should be checked for clogging. One of the other things that I think sort of goes without saying, we are dealing with a fine-grained particle material. If you breathe cement, all right, you breathe a lot of cement dust, it is going to cause a problem because inside of your body, the human body is made up of water. And when that water comes in contact with cement, it can be an issue. So you want to make sure that people are handling these materials correctly. Generally, you don't want to stack cement more than 14 bags high. Typically, you'll see about 7 bags on a pallet. That means you should have 2 pallets of cement. So when you go down and you see the greatest Jenga game that's ever going on at your local Lowe's or Home Depot, where you see you have 47 stacks or pallets of cement high, the idea there is if you stack these materials on top of each other for a long time, you'll get something called cement pack, and I think each one of you have probably experienced that, where it feels like a rock when you pick it up, and it's because the materials have really all been consolidated down on top of each other. So you want to be real careful about that. Water is good to add to the system as well, so we'll bring water in. I think most of you probably have an imagination of what water looks like and how that could be added in a large-scale industrial hose to the system. The raw materials will then typically be added, weighed out and added. Typically this is going to go into the back of the truck, but I will talk about some other concepts here. The materials will be weighed out, they will be brought up, they'll come into the back of the truck where they'll fall down into the truck, and that's when the mixing action is going to take place. So truck mixed concrete. What we'll talk about here, typically you can't go above about 63% of the volume of the overall truck. Typically you're going to put 70 to 100 revolutions on. They're going to be somewhere between about 16 and 18 revolutions per minute. The truck will be rocking back and forth, and you will be mixing the concrete in the back of the truck during that time. Generally, the truck will then leave the plant and it will go out with an agitation speed of about 2 revolutions per minute till it gets out to the construction site. The concrete is supposed to be discharged before it reaches 300 revolutions per minute. Okay. Now, one of the things that I will point out for those of you who are going to be going on the tour here, we will actually view 2 types of plants. One of them will be this truck mixed concrete application, and this is the plant that is located very near campus here on South River Road. The other type is more of a vacuum mixed or a central mix type operation. We'll talk about that in a second. For anyone who we're setting up separate trips for you, you can just ask. I think it'll become obvious what type of operation it's going to be when you go out and look at it, but you'll see it there. One of the things that I'll point out in the delivery system, there are trucks that discharge from the front. There are trucks that discharge from the back. Front-end discharge trucks are somewhat the rage at different places. I can tell you that in certain regions of the country, they will pay a premium to have front-end discharge trucks. I will tell you that at least in my father's business, he will pay a premium, and he's a very cheap man. So he doesn't pay a premium for very much, but he will pay a premium for the front-end discharge truck. The basic idea here is the driver has more visibility. All the controlling is done from the cab of the system here, so the driver is essentially sitting in the truck, has the ability to move move this back and forth. Also can do all types of different additions or whatever from the cab. The truck also has a little bit better balance. Not like the truck is going to be out there dancing or singing or anything like that, but the truck has better balance because you can imagine when a truck goes in and it weighs 35 tons in the spring, and all of a sudden it's on mud and it comes back out of wherever it went into at 15 tons, it's going to operate a little bit differently, and you tend to get a lot less trucks stuck because they're better balanced front to back with the front end discharge type of machine. Here the driver can actually see where everybody's at, can be lowering and raising the chute to allow the materials out or stop based on what he sees the construction crew doing. It's a little bit easier for them to operate. Rear discharge, one other thing that I will point out here, the driver can do an awful lot from the front of the truck. The driver can even add water to the truck, typically from the front of the truck. One of the days we were sitting and a driver pulled up, he handed me the tickets. This was at the lab here. It turns out that it wasn't a big issue because we were just using the concrete as a subgrade. I was chatting with the driver and he gave me the nod that, oh yes, this is good concrete on a Friday afternoon. And as we were sitting there, he was playing, it looked like playing the piano on his keyboard, on the dashboard. And while he was doing this, there was a group of graduate students going wild, taking all the measurements that you would think you would want out of your concrete. They were taking slump, fresh air, everything else. And the whole time you were doing the measurements as graduate students, he was adding water to the back of the truck, which meant that you were measuring something that didn't have anything to do with what was in the back of the truck at the time. And I say this because I think it's important that you understand where water can and can't be added in the overall process. Back of the truck is typically where the business is going to take place for a rear discharge truck. Here you can see it's the exact same thing, only it's in the reverse order. One of the other things that I will point out here, when you look at the front discharge truck, there's a little bit less climbing around on the top of the truck that takes place than you see here, and this is a big safety issue. This time of the year, when water undergoes that massive phase change, you get drivers crawling all over the back of the truck. It's slippery. One of the biggest insurance causes or insurance claims that you're going to see is drivers falling off the back of these trucks. So you want to do as much as you can to make sure that the system is going to be safe. The inside of these drums, here you can see a picture of it. I am not going to go through all the different thicknesses on steel and things like that, but you basically have a series of baffles inside of the truck. This is going to revolve, and it's going to allow the concrete to be picked up and dropped down at different points inside of the system. Some of the other things that I will point out in the truck, you will see these tanks. These tanks are essentially there to hold water. The water that they are holding is not to adjust the engineer's mixture proportions that he's worked for 3 months on. They are there to clean up the truck. All right, inside of the system, you will see something like this, which is typically your water meter inside of the truck. The chute on the back of the truck that we can see here, you'll see this is becoming more and more popular as a way to measure the rolling resistance of the truck. One of the things that you will notice is on the back of the trucks, the drum will be rotating. One of the ways that they can make sort of a large-scale rheometer is to measure the electrical resistance that it takes to roll that drum, and that gives you a property that is somewhat related to the fresh properties of the concrete. And you'll see a lot of trucks will now be monitoring this energy or the power that's going into rotating the drum. And based on a truck-by-truck basis, mixture-by-mixture basis, they can get pretty close to controlling a consistency inside of that truck. You'll also see quite a bit of these controls that I mentioned before. With those controls, they're going to be doing all kinds of things, raising, lowering the chutes, adding water, different things like that. There will also be a counter placed on the drum. Many times this counter is below the driver's seat, counts how many times the drum has gone around. As I mentioned before, you want to discharge the concrete before it gets to 300 revolutions. Now, one thing that I will point out about this counter is, and I ran into this quite a bit, the state will look at the counter. Many other of the people that buy concrete from the ready mix producer do not look at the counter. So if your truck shows up with 47,000 revolutions on it, all right, it's highly likely that it didn't actually have 47,000 revolutions. The driver forgot to reset it. When they're going out to a job where someone's going to be inspecting this, they typically are going to be making sure that they have tapped off the water and the water shows up and all the tanks on the back of the truck are full, so that the truck didn't stop off or theoretically didn't stop off anywhere where the driver added a little bit of extra water to the system. And they're also going to be resetting the counter every time that they leave the plant. I will talk about the idea that trucks are kind of like camels. They will hide water in very funny places. All right, when you are washing out the truck, you will frequently see that we will actually have quite a bit of water that will typically be in the truck even after clean out, and that's something that you need to take account of somehow in the overall process. Now, one of the things, and I'm not going to have lots of time to go through this, but you will see when we go to the plant, you will see screens that pop up that look something like this. There's a lot more control in how the materials are being batched and placed in the back of the truck at this point. Here you can see sort of a cartoon version of everything that we talked about before. You've got the admixtures down here. You've got the aggregate bins up here. The materials are being weighed out. They're being dropped into the bins. They're coming into the overall system. You've got everything coming in. You've got the cement being dropped into the system. So it's an automated version that the batch person is looking at as the materials are coming in. They can call up a particular mixture proportion. This will be preconditioned to weigh out those materials, add them in a specific sequence, place them in the back of the truck, which is a little bit different than what we've seen on a lot of the other pictures. I'll jump back here, back to this type of schematic where we see up in the top left-hand side here. This person who's running the plant is actually using these controls down here to open and close those clamshells. These are the scales of the different materials that are being weighed out. A lot of that is going away, and you're seeing a lot more producers moving toward this type of an operation. Batching and weighing. Batching is the process of measuring out the ingredients and introducing them into the mixture. This should always be done on a weight basis. There can be discrepancies if you're doing this on volume. One of the discrepancies we talked about before was the bulking of sands due to moisture contents. The only thing that we are typically going to do is we are only going to typically weigh out or measure out the liquids based on volumes, and here we're typically talking about the admixtures based on their volumes. Now, I will point out here that the accuracies of the different, well, before I jump on, there is a small segment of the industry, so I say this, in general, you always want to be weighing out, massing the materials, taking the weights of the materials. There is a small segment of the population that does volumetric mixing, and I will show you a volumetric mixer. We'll talk about some of those issues. But in general, everything you want to mass, it's going to be much more accurate. It's going to be much faster. Accuracy for the individual materials going into the back of the truck. Here you can see the accuracy of the given materials. Cement and water, we want to be within plus or minus 1%. So if you're putting 600 pounds in the back of a truck, you sort of can figure out on your own what 1% of that is going to be. Aggregates, generally we're adding the materials very quickly, so we'll give it up to a 2% variation. Admixtures, because of the power that the admixtures could have, and because we're talking about relatively small volumes, we're looking at about plus or minus 3%. You want to be using at least 30% of the capacity of the scales typically. And in general, the chemical admixtures are going to be in solution because if you have under or over dosaging, if you put in twice as much superplasticizer as you expected, you're going to get a very, very different mix in the system. Now, as I mentioned before, the older type of technology, you will see someone here, and both of these, I have to tip my hat to PCA. I don't know where they found plants that were this clean. I think a cleaning staff must have been employed for about a month and a half to clean these up. I've never been at a plant that doesn't have about 3.5 inches of dust on everything in the entire plant. But here you can basically see they're actually looking at the dials. The dials are telling them the weights of the materials, and then they're essentially controlling the conveyor belts and controlling the openings and closings of the chutes down here. More modern, you're actually seeing the process being done here, where you've got, I believe this is a plant out of the Chicago area, where you've essentially got everything is being computer controlled, and they're essentially pulling up the batch ticket They're pulling up the mixture proportions. They're typing in the amount that's going into the back of the truck, and then the equipment is essentially taking over. Here you can actually see, because of the configuration of this particular plant, a lot of stuff is done on closed circuit TV, because you should be able to see the truck through this window, but you would have to really be a master to be able to look through that window and get down to see the truck, because it's below where we're at. One of the things that I will point out here, one of the things that you want to watch out for, and I mentioned this before, admixtures are typically going to be in clear containers. They're typically going to be inside of the batch room. You will typically find them located behind things like coat racks and everything else that's been stacked up in front of them. They are not supposed to be behind things like coat racks. The reason that they are in for the dispatcher or the batch person to actually be looking at is so that they can see the admixtures are actually coming into this, they're filling up, and they're being discharged. One of the problems that you can get into, especially when these materials start to freeze in the late season or in the winter, this can be an issue because their liquids, their fluids, and the systems could freeze. You want to make sure they're being batched out. Another thing that you want to watch out for is gumming. The valves on here, if you start getting a lot of evaporation or slow leaks at the valves, they can gum up and they can stick open or closed. And you want to have a good idea of, are the materials actually getting added to the back of the truck or not. So this is one of the reasons why these are inside. A lot of time the batch people actually like the fact that these admixtures have to be inside, because they can use this as an excuse of why it needs to be 70 degrees inside of their office during the winter. Got to keep those admixtures warm. Different types of mixing plants. As I mentioned, there's stationary mixing, which will be done on the job site. There's central mixing, and this is typically our ready mix. And then there is mobile batching. The art of mixing, a few things that I will point out here. One of the concepts that you will hear frequently throughout the industry is just enough is good enough. You want to get just enough mixing on so you can turn over the equipment as quickly as possible. Too little mixing is bad because it gives you inadequate mixing, gives you low strength, a lot of variations. Too much mixing, though, may not necessarily be the best thing in the world. You will start to break down the rocks. They'll actually start to crush inside of the mixer. You can break down things like fibers when they're crushing inside of the mixer. You can decrease the air content. And then again, everything is related back to production rates. So you want to get the materials out of the mixer and out of the batching as quickly as possible. The goal is to make something that's as homogeneous, uniform, and low variability as possible. Typically, we've got to get enough energy in the system to really start breaking things down. A little bit of information. Mixing time is going to depend on almost everything that has to do with your equipment, and some general rules of thumb on timing. Some of the things that we should point out here are related to the one of the things that you need to start to look at when you start to talk about trip time. It takes a few minutes to load the truck. Typically, they're going to then pull out. The driver is going to then figure out whatever he needed to do while he was in there. He's going to make a phone call home. He's going to go get a candy bar, get a soda, do whatever else the driver is going to do. Allegedly, he's mixing the concrete, checking the concrete, traveling to the project, unloading the concrete, washing up, and returning to the plant. This trip time can vary quite a bit. And one of the things that you will find out a lot of times about ready-mix trucks that are going out to different construction sites is they migrate like pack animals. So every 5 or 7 minutes one is leaving the plant, but somehow they show up in flocks, where 5 or 6 of them will show up at a time. And most typically the drivers will show up because they've stopped for lunch or they've stopped for coffee, or it was easier to stay all in CB range talking to each other. You want to make sure that they stay relatively evenly spaced as they're getting to the site. You also want to make sure that no trucks are getting out of line where they're jumping ahead of other trucks, because the concrete, once the water hits the cement, you're starting the overall process. One of the other things, and I think we'll probably end up at this point, one of the other things that is kind of fascinating, and we'll take a little bit of time to look at this when we go over to the ready mix facility, and I think at each of the facilities that we set up tours for different people at, one of the things that we will notice here is they have moved to quite a bit more automation. So it's not the idea of I've got a truck, I'm going to send it out to site, I hope it comes back someday. You'll find out that Big Brother is watching quite a bit, and they're actually doing quite a bit using GPS and using monitors on the truck to figure out where the truck is. So here you can see trucks with different numbers, and it's of course off the edge of the screen. So those of you who are following along with your own version of the slides, look way off to the point that's missed on the screen. You'll see the truck numbers. Those are not the numbers painted on the side of the truck. It's not in honor of Daytona or anything like that. The truck identification number, it will tell you how many minutes the truck has been out, tell you where the truck has been, tell you the driver. It will also start to report back other information. So one of the coolest things that I think I've seen, one afternoon I sat in a producer in the Austin area. I sat inside because it was about 197 degrees in Austin in the middle of July, and I watched the map of Austin with all these little lights all over with all the trucks. The trucks would head out on the site. They would be one color blinking. They would get to the site. They would turn orange. They were sitting and waiting. When they were coming back, the little light would turn green because the truck was now coming back. So it made it a whole lot easier for the dispatcher. I think you're going to see people using this a lot more because they can also start to control things like the resistance on the drums, water that's added, things like that. We will pick up here and we will start to talk about stationary mixers on Wednesday.